All right, so welcome everyone to the 13th session and the week 7 of the data science program. And once again, I hope everyone has been doing very well. I hope your week was also splendid as well. Today we are going to be diving into what we started last week, and I believe everyone here is prepared. I believe your mind is already set to learn, and I hope you're going to get a lot out of this class. All right. So, but before we start, I'm just going to go over the quiz I gave us last week on machine learning, just to recap and set the tone for the class. For the second assignment, I'll just do a quick review before we start tomorrow's class. Yeah, during tomorrow's class, I'll go over that. I'm not done with the marking yet, but assuredly by tomorrow you would have your hopefully a lot. I have a very tight schedule lately, so I've not been able to meet up with the marking. So, but definitely you'll get your grades very soon, and we'll go over the correction on that. But I just want to commend everyone here on your performance so far. Most of us, I just look at your assignment and I'm like, yeah, this person understands what we've been doing so far. So I'm very confident in most of your abilities at this point, and I'm very sure that before the end or at the end of the program, like you'd be very confident with what you've learned so far, and I too will also be confident. So yeah, basically that's just that. We're gonna be starting right away. Okay, so let me share my screen. All right, so I'll quickly go over the um yeah the quiz assignment. Yeah, so to help us recap on what we did last week. So yeah, I gave us two assignments. The first one, which was the visualization assignment, and also the second one, which is this. So because of the topic we'll be treating today, I would like to just go over this, at least to freshen our memory and give us a start, a very good start. So the first question here was, what is machine learning? So, and this is just a very basic, right? So obviously the answer is it's a field that gives is a field of study that gives computer ability to learn without being explicitly programmed, right? So that is basically what ML is. We discussed that in the last class. If you were not in the last class or if you missed any part of the class, please go back to the recording. The recording is on YouTube. The link was posted on the group on the Google Classroom. Endeavor to go over it and just catch up with what we've done so far, right? So the second question, which of these are types of ML, types of machine learning? So basically, we did these two, right? So I told us supervised ML, right? Unsupervised ML, and reinforcement learning. So these are the three. I don't know what happened. I just don't know why this network always acts up whenever I'm in class. I don't understand. Let me just share my screen again and hope it doesn't repeat itself. Okay, so yeah, so as I was saying, I told us we are going to dwell mostly on supervised machine learning, right? So most of what we're going to be doing in the remaining weeks will be centered around supervised learning. We might, if there is time, touch a little bit of unsupervised learning, right? So most of the algorithms or most of the things you'll be doing with machine learning are around supervised learning. So that's why we are going to focus more on that. So the next question here, what's the label data? So basically, you already know this if you're in class. Data with specific markers, data items with tag labels. So basically, this is it. And which of these machine learning requires label? So I told us this the difference between supervised and unsupervised. You need to teach supervised machine learning by showing it labels of your data, right? The required output. So if you want to train a machine learning of a cat, you have to tell that this is a cat, right? That is supervised machine learning. So the machine learning that requires label is the supervised machine learning. So I also have which of these are types of machine learning tasks, right? So these are the two that we mentioned. Just to go quickly, which of this is not a machine learning algorithm, right? So vectorization, linear regression. So if you've been in class, all these questions should be easy. Scikit-learn is built on NumPy, false or true. I told us this, so should be a bonus question for you. What is the main goal of clustering in machine learning? So I told us clustering is an unsupervised machine learning technique and is the most common one. So clustering is basically used to separate data points into naturally occurring groups. So you don't tell the computer how to classify or categorize the data; it learns it by itself in an unsupervised manner. So yeah, that is it. And this, I talked about something about confusion matrix if you're in class, which I was saying where I said why would they name name it confusion matrix, right? So it's an evaluation metric for classification models. So we're going to talk about that too tomorrow. So I talked about I asked which ML library is used for general machine learning. I think this is where most of us will feel it. Right. I mentioned TensorFlow, PyTorch, and Scikit-learn as the libraries in machine learning, but I specifically said that Scikit-learn is used for general machine learning. PyTorch and TensorFlow, they are more specific for deep learning. So if you want to go into deep learning and building AI, these are the libraries you will use. But for general machine learning, like the ones we are going to be doing, you would mostly use scikit-learn, right? So, and this is the library we're going to be learning next week, right? So basically, this is it for the assignment. I just wanted to go over that. So we're going to know have a good starting point for today's class, right? So I'm just going to tell us how we're going to go with the lessons or the classes today, tomorrow, and next week. So for today, as you can see on the screen, we're going to look at linear regression. Right, we're going to start with linear regression today. Tomorrow, we're going to look at logistic regression. So we're going to dwell mostly on the concepts and the theory of it. Right, it's very, very important that you understand it. So by next week, we're going to be now implementing what we've learned in Python. That is when we write code and do everything we are doing in machine learning. We're going to build our models, do a lot of things, right, that involves building machine learning algorithms. So, but for this week, we're going to just introduce us to the algorithms that we're going to be two of the algorithms. So this week would be for linear regression and logistic regression. Then we're going to demonstrate it next week, and hopefully next week or upper week we're now going to look at the remaining algorithms, right? Decision trees and SVM, right? So if you remember the last class where I talked about the algorithms, I mentioned some algorithms there, and these are the ones we are going to be looking at. So let me quickly see. Where is that again? All right, so this was where I mentioned the algorithms. I talked about linear regression and logistic regression, right? I also talked about decision trees. and random forests, and support vector machines. So we'll be looking at this one, two, three, three different, although linear regression and logistic regression, we'll look at them this week. Then the remaining weeks, we're going to try to look at the remaining algorithms. But for neural network, we won't be covering it in this course. That is a very advanced ML technique, right? So it won't be covered here. And we might also look at some other algorithms I didn't mention here, if time permits, right? But what we aim to achieve is to help you understand how to approach a machine learning problem. Whenever you see a problem that requires machine learning, you actually understand the right way to think about it. So it's good to understand or know how to use different algorithms, but understanding how to use an algorithm effectively to build a model is even more better, right? So we're going to try our best to train us on that and to teach us that. Yeah. So now for today, we're going to be looking at linear regression. So before I proceed, please I just need feedback in the comments in the live class. Can everyone hear me? And are we good to go? All right, perfect. So today we're going to look at linear regression, introduction to linear regression. Now, we are now entering the main thing, right? Although this is the simplest algorithm in machine learning, is considered the simplest algorithm. So wherever you learn machine learning from, or when you start learning machine learning, you most likely start with linear regression. So it is easier to enter from here, right? So today we're going to try as much as we can to dissect linear regression and open us up to the world of machine learning, right? So now, basically this is the outline. What is linear regression formula, types of variables in linear regression, what is the regression line, types of linear regression, evaluation metrics in linear regression, and then assumptions of linear. So basically, you can see from here we have a lot to talk about. So just breathe in and out, right? Let your attention be 100%. Because if you lose any, if your attention is lost, it will be difficult to trace it back, because most of the things we are going to be talking on or building on will be based on what I have said. So please just try as much as you can to be attentive. Some of these things are new. Some of the concepts, some of the words I'll be using might be entirely new to you. Some of you here, you might be already used to this. That's fine. But I believe majority of us here, we are new to this. So try as much as you can to pay good attention. You can always go back to the recording and just brush over it and try to understand it better. But I believe there is this difference in a live class where you are in real time listening to someone teaching. So just try as much as possible to get the most you can from this class, right? So the question, what is linear regression? So for some of us that did science or mathematics rather, I believe everybody did mathematics, so you should probably have heard of linear. When someone says something is linear, like it's what should come to your head, or what you should think of first is, can someone tell me, does anybody know like what linear mean? Like back in our mathematics class, I don't expect everybody. I don't expect you to know. I'm just trying to know if we have that knowledge, right? So exactly. So as you see, some of us here, I think we still remember our mathematics. So yeah, linear means straight line, right? So linear is straight. Anything that is straight. So is it that we can still remember the classes we've had back in the days, or we've already gone ahead of this class, which is awesome. If that is the case, then that is very, very beautiful. Um, it's going to make everything easier for me, myself, and yourself included. I believe that is the right approach to learning. You go and read ahead of what we have, right, or what we are going to be doing, and then just come to class and just try to fit it in with what you've learned already. So you get a very holistic understanding. So now linear is basically straight. When they say something is linear, that means I'm talking about something that is straight. And now regression. Regression is mapping a relationship between two variables. Let me come again. Linear is what? Straight. Regression is mapping a relationship between two variables. So now the variables now that we are talking about in this case, we'll talk about the kinds of variables, right? So but just follow me here. The variables here, they have a relationship. So that is why you're even trying to use or trying to use this algorithm, because there's a relationship between these variables. So that's why you're interested in the data. So you have data points, right? And then regression basically maps the relationship or tells you how this particular variable is relating or relates to this other variable. Do you understand? So now in linear regression, this is a type of regression that maps relationship between two variables that have a linear relationship. That's very important to know. The two variables, now we are going to actually build on this, but this is the basic. In this case, we are using two variables because we get to a point where we'll now start talking about more than two variables. But this is the basic and where we're going to start. So linear regression is trying to map out the relationship between two variables that have a linear relationship. That is very important to know. For you to use linear regression, the variables you're working with must have a linear relationship. If they don't have a linear relationship, then you can't use linear regression. Keep that at the back of your mind. So now, what does linear relationship mean? As you've all said, you said straight line, right? The same thing for linear relationship. Remember when we were talking about scatter plots and when I was talking about correlation? This is why it's important to always follow our classes. So when I'm saying things or making references, it doesn't seem strange to you. I remember when I talked about correlation, I told us that we have what's positive correlation and we have negative correlation. So now I used an example there. If a variable is increasing with another variable, right? It has or exhibits a positive correlation. That's what I said that time, right? Now, bringing it back to linear regression, these two variables, they have a linear relationship because as one is increasing, the other one is increasing, right? So, but there can exist two relationship. There can exist two linear relationship. It can either be positive linear relationship or negative linear relationship. But what you should have in that relationship is that as one is going up, either the second variable is going up with it or is coming down. There's just this line that can be used to interpret the relationship, either going up or going down. So in cases like relationships that have a kind of curve or bend. Okay, let's say like you want to study the effect of drug now, right? The effect of drug on a particular ailment. Let's say there's a particular sickness that you are trying to create a drug for. So you want to test the effect of the drug on that sickness. So you give the drug to somebody, and then at different time intervals, you measure the effect of the drug, right? So you measure the effect of the drug, and you see that as the time is increasing, the drug is becoming more effective. So that is exhibiting a linear relationship. Get me here. It is exhibiting a relationship, right? It is moving upward, both of them. But as the time is increasing, the drug is becoming effective. It's becoming effective, but as the time increases to a certain point, the drug becomes ineffective. It is not doing anything again, right? So it gets to a point where the relationship rather plateaus. The thing just ends. So if you plot it in a graph, you are going to see a line going up, and then as it's going up, it now stops somewhere, and then you now see a curve there. That is not a linear relationship. That's actually not a linear relationship. A linear relationship is a relationship that it will continually go. Like as that one is increasing, that other one will be increasing. It's just like exam score now. Two variables, you have exam score and you also have reading hour, like the time a student spent in reading his or her book. So the longer the hour spent in reading, the higher the score. That should be the normal what should happen normally, right? The higher the time spent reading, the higher the score. So that is a linear relationship. So there is no point where the relationship will plateau, right? The only thing that will cause it to stop is the score. The score stops at a particular point. So that is just the only thing. But if there is no range to the score that a student can get, the relationship between reading hour and score will continually going in a linear direction. So I'm trying to take my time here to explain a linear relationship so you understand exactly what it is we will talk about today. So basically, as you can see here, linear regression is one of the easiest and most popular machine learning algorithms, right? So it's a statistical method. Yes, most of these machine learning algorithms are actually statistical techniques. So they were built or created by statisticians, right? But we are now trying to implement or use them in data science. So linear regression, even before we have data science, before everybody started knowing that data science is something, we've had linear regression. So like as a statistical technique, right? So now it was now adopted as an algorithm that can be used in machine learning. So, and that is why I say it's actually the easiest machine learning algorithm that that we have, and so it's a very good starting point for those that want to learn machine learning. So, that's it for that. I just hope you've been able to just gain intuition on what I've said so far about linear relationship. So, it is used for predictive analysis. So now there's something you need to know. Over the times, over the weeks, over the sessions we've had, over the classes, what we've been doing is what we call descriptive and exploratory analysis. We actually have different kinds of analysis. If you take a data analytics course, they're going to tell you that we have different kinds of analytics. We have predictive analysis, we have descriptive analysis, we have exploratory analysis, we have prescriptive analysis. So there are several kinds of analysis. So linear regression is a supervised machine learning algorithm that is used for predictive analysis. So this technique now is not, you are not trying to use it to understand your data, right? You are trying to use it to make predictions. That is the end goal of linear regression. That is the end goal of any machine learning algorithm that we're going to talk about, right? And just be noting all these things that I have that I have bolded. So it is used for predictive analysis, and it's also used to make predictions for continuous or numerical variables. So this is why I sent that video. I sent the the video on data types. I resent it again. I don't know what happened and why some of us didn't get the other one, but I made sure I sent it to the group. So if you have gone to understand what I'm talking about here, so linear regression is used to make predictions for linear or numerical variables. So one thing that you're going to get used to in machine learning is the different criteria, the different assumptions, or the different things that have to be met for you to use a particular algorithm. That's what makes you a good data scientist. Remember, I said for you to use linear regression, your variables must have a linear relationship, right? Now, I just said on that one. Now, the output or the thing you are trying to predict must be a continuous or numerical variable, right? Such as sales, salary, age, product price. So as you can see, we can represent these variables in numerical form. So when you have something like this and you want to make predictions, your best bet is to use a linear regression algorithm. Although there are also other algorithms you can use for this, but linear regression itself can be used for this kind of prediction. Get that too. Note that. So let me just go through this here. So linear regression algorithm shows a linear relationship between a dependent and independent variables, variable or variables. I'm going to explain this. I'm going to explain what dependent and independent variable mean as we are moving forward. But just understand that linear regression helps to show a linear relationship between a dependent variable and an independent variable, right? So that's why it is called a linear regression, right? So this is just trying to explain or say the same thing that I have been saying since. So now another thing you have to know is that the linear regression model provides a sloped straight line. This is one thing you're going to see constantly during or when you're reading about linear regression or when you're working with linear regression. Straight line. That straight line that you're going to see, I'm going to show us as we are moving forward in this class. That straight line is your model. I'll explain that. So, but just understand all these points I am making. I'm trying to give us intuition, help us to just pick up the idea behind this linear regression algorithm. So, because this is potentially a new thing to most of us. So now, let's move on. Let's move on. So we have the linear regression formula. The linear regression. Let me zoom out. The linear regression formula. So what you're seeing on your screen now is the linear regression formula. So this is just a side question. It's not like does this formula bring to mind any kind of formula or any other formula in mathematics that you can remember? This actually looks very similar to a particular formula that we use in linear algebra, right? So let me not just go there. So this is actually very similar to the equation of a straight line. Equation of a straight line. If you remember, when you were doing linear algebra, they taught you y is equals to mc square. So that is the equation on a straight line. So it's the same formula that we use in linear regression. Why? Because linear regression is trying to map out relationship in between two variables that have or relationship or two. Okay, let me rephrase. Linear regression is trying to map out linear relationship between two variables, right? So it uses this formula to do that. So as simple as this thing is, this is the machine learning algorithm. This is it. But we're going to build on it, right? So that is why I said let's start from somewhere. So, but this is basically the starting point of linear regression. So I'll explain all this, right? But let's move on. So we have y here, right? We have this symbol beta 0. We have beta 1, and we have x here. So this y here is basically the prediction that the machine will make, and these other parameters we have on the other side are what would be are the things that will be used to make this prediction here. So remember I said that linear regression is trying to predict something based on other things, right? So it's trying to make a prediction based on what it has seen already. So this y is the prediction here that is making. Why this beta 0 plus beta 1 xi? These are the parameters or the things that will be used in making this prediction. So this one that you have here is the intercept, right? The intercept, we'll talk about that as we move on. I'll try as much as possible to illustrate this in diagram so you can understand it, because this theoretical overview can be abstract sometimes. So we have beta 1, and then we have x. So one thing you have to know here is that this x you are seeing, this is your variable, your independent variable. Remember I told you we have independent variable and dependent variable. So this is your independent variable and this is your dependent variable here. So this is the variable you are trying to predict here, and this is the variable that you are using to predict this variable. So the relationship between this variable and this variable is this equation. It is mapped out in this equation, right? So what the linear regression algorithm tries to do is to get values for this beta 1 and this beta 2, that is the intercept and the slope, that would give you a better or a good or that will best describe the relationship between x and y. So the learning aspect of the machine learning in linear regression is in this beta 0 and beta 1. This is what it is trying to learn. It's trying to learn the values of these two values here. So this might not come you might not understand it immediately, but just try to be getting those salient points I'm making. This is the relation, this is the regression formula, and this is what you're going to be coming across mostly. But we are actually going to build on this. So I need you to understand what we just said now, because when we talk about the types of linear regression, I'm going to introduce you another formula that is an adaptation of this particular formula here. So don't be scared. I know some of us might be like, I don't like maths. Oh, this data science want to finish me. Well, should I say I'll run away from maths? Now I'm meeting mathematics. Like, I understand, like, but I just need you to understand the concept. Nobody would, no, you will not do maths. Once we start using scikit-learn now, you will realize that it is so simple, because you'll be using the functions in scikit-learn to do all the things you want to do. So for you to use scikit-learn, you need to understand exactly what it is you are doing. That's why I'm taking my time to explain all these things to us, right? So don't be scared or don't be intimidated by all these things I am showing us now, right? So I just understand this one first. So let's just move on because of time. I want us to stop very early today. So now we're going to look at types of variables in linear regression. So I've been talking about dependent variable and independent variable. So, but some of us didn't understand those concepts or those terminology. So I will explain it now. So now, as you know, linear regression is trying to map out relationship between two variables. So the variables here are what dependent variable and independent variable, right? Independent variable. So what is the dependent variable now? The dependent variable is your target. It can also be called target variable. So anywhere you see target variable, you just know it's the same thing as dependent variable. Anywhere you see dependent variable, you just know it's the same thing as target variable. They can be used interchangeably. They can also use another name for it. They can also call a response variable. So just understand the concept, because the name can differ depending on where you're learning from. So, but mostly the name is usually called dependent variable. So the dependent variable is actually the variable that you are trying to predict, like the sales price, the what we mentioned earlier here, like sales now is a variable, salary, age, product price. These are the things you are trying to predict, right? So these are the dependent variable. And why are they called dependent variable? They're called dependent variable because they depend on another variable for the prediction, right? So the variable they depend on is called the independent variable. Those ones don't depend on anything. That is what you are trying to use to predict the dependent variable. Like the example I gave, students study time, time of study or time used for study, and the exam score of a student or the student. These are two variables. Now, between these two variables, can anyone tell me which one is the dependent variable and which one is the independent variable? Let me see if we are following or if you understand what I've been saying. Okay, I'm waiting for us. Is anybody typing? Okay, someone said study hours independent. Someone said time is independent, while score is dependent. Okay, okay. All right, great. So I believe we understand that. So that is actually correct. Time is the independent variable because we want to use time to predict the hour or the amount of, or sorry, we want to use time, which is hour, to predict the score that the student will get based on how long they studied. So the exam score in this case is the dependent is dependent on the time, right? So just try to understand that. So basically, these are the things that you'll be getting to. Yeah, these are the terminologies you'll be getting to like work with during the course of machine learning generally, not just linear regression. So just try to understand them. So now, as you can see here, this dependent variable is the variable you are trying to predict or explain, right? It's the outcome you're interested in. So these are the things that you would use to know which one is the dependent variable. The dependent variable is the outcome you are interested in. So in this case, the outcome we're interested in is the exam score. That is what we are interested in. We're interested to know the exam score based on the amount of time that the student put in studying, right? So, and it is in linear regression, it is often continuous, as I've said before. So this the the dependent variable differs depending on the algorithm. So in linear regression, it is continuous, a continuous variable, while in logistic regression, it is a categorical variable, right? So now, remember the example I gave us the other time that we are trying to classify email as either spam or not spam. So the dependent variable here is whether it is spam or not, right? So, and this dependent variable, it is either this or that. It's just two different categories. So unlike linear regression, or unlike the variable in linear regression, this is not continuous, right? This is not a number. This is not something that you can. This is not basically not a numerical continuous variable that you understand or that you know. So you can't use linear regression for that kind of um, problem or task. You are actually going to need to use a different machine learning algorithm, which we are going to talk about tomorrow, and that is logistic regression. So I want you to start to understand how to segment these things and how to place them so you don't get everything mixed up in your head. So that's it for dependent variable. Okay, now exactly. So this is the example I've been giving. So imagine you're analyzing relationship between studying hours and exam score Y. So the exam score Y is a dependent variable because it's the value you're trying to predict based on. So I believe this is just giving you more on explanation on that, right? So let me just go to this formula to show you where all those things fit. So this Y here now is your dependent variable, right? And this X here is your independent variable. So your X here would be the time. All the data of the time will be here, and the data of the prediction rather, or the data of the exam score will be here. So we're going to actually explain this thing so you understand how everything fits in the formula. So let's just move on because of time. Right. So for independent variable, it's also called predictor variable. So you can call it independent variable or predictor variable. So it is called predictor variable because we are using it to predict a value. So we are using time in this case to predict exam score. So it is not dependent on anything. That's why it's called independent variable. It is not dependent on any other variable, right? It's the orga, right? It's the one you come and meet to ask question like, okay, what exactly will be the prediction for? So you get the gist, you get the point. So that is basically what the independent variable is. Is the orga, is the chairman in this setting at this point. So the dependent variable now it depends on this orga, right? So that is basically the relationship mapping in linear regression in this case. So now let me just go over the details here. So you can see that the variable influences the dependent variable, right? It's often used to make predictions about the dependent variable, right? So basically, same thing that I've been saying. So now we have different types of independent variables, and this is actually what differentiates linear regression or splits linear regression into two types. We're going to talk about that one. We're going to talk about it. So, but different we have different types of independent variable. We have a single independent variable, and we also have plenty independent variables. That is multiple independent variables. We're going to give you more understanding on how it is used in linear regression. So, for example, what I've been saying since about the hour spent in studying and the score, the exam score, is a single. In this case, we have just one independent variable. So in a case now where we have several independent variables, like we have hours, number, amount of time spent in studying, we also have gender, we also have level, we also have a lot of things, maybe like economic status. We also have number of times eating in number of times you eat in a day. So these are all variables now that you can use alongside the number or amount of time studied to predict one thing, which is the exam score. So most of the linear regression problem or task you be performing in ML, machine learning, usually involves multiple variables, multiple independent variables, because you want to understand how because in life is complex, right? We can't just single out something and say this is the thing that is responsible for this. So we can't just say that the time used for study is what or the only thing that influences the score a student will get. There are actually a lot of other things that can influence it, right? You can have people that don't eat very well, so they can't think well, so they don't they can't actually perform a lot of things, right? Because they're always thinking about what to eat, how to get money, how to do that. So there are variables that combine to affect that particular output, which is the exam score in this case. So that is the most realistic way to perform linear regression, by bringing different variables and using it to and plotting or mapping the relationship between all those variables to the predictor, or sorry, to the dependent variable. So that is just it for independent variables. We have single and we have multiple variables. So okay, there are an example here is, as you can see, for multiple variables, you might consider like factors like studying hour, which is one variable, difficulty of the exam, another variable, student prior knowledge, another variable. So there are just a lot of things that you can just think of. Like you can actually think by yourself of variables that can potentially affect exam score, right? And just include that in as your data and use it to predict something. So yeah, machine learning is very interesting. So that is it for the types of variables we have. So just know this, that dependent variable can also be called target variable, and independent variable can also be called predictor variable. So now an important note: linear regression assumes a linear relationship, I've said this, between independent and dependent variables. So there must still be a linear relationship between these two variables, right? So you just have to, that assumption has to be met. At the end of this class, we're going to talk about the assumptions of linear regression. So it's some part of what we're going to be talking about, right? So if the relationship is not linear, you can use other kinds of um, machine learning algorithm, right, to map out or to map the relationship, or you can introduce non-linearity into the equation, but that is kind of more advanced. Hopefully, we would have enough time to talk about that, right? So let me quickly move this. Okay. So the second thing to note here is that logistic regression is for categorical variables. So if you have categorical target variables, you can't use linear regression for that. You have to use logistic regression. So we'll talk about logistic regression tomorrow. So in this case, it can be maybe you want to predict if somebody will pass or fail the exam. So these are two different categories. So it is not like exam score where it is a numerical output or numerical target variable. So all right. So by understanding these variable types, you can effectively set up and interpret linear regression models for continuous prediction tasks. So there's something I want to tell us. Please and please don't be carried away with the fanciness of all these machine learning tools and trying to know the algorithms and everything. If you understand the fundamentals, those are very, very, very great. Those are very good because that's what will distinguish you or make you a very um, well sought data scientist, right? Because you know how to use them. But what actually makes you more effective as a data scientist is understanding all these assumptions that I've been talking about. So you know when and where to apply this algorithm and what to do when something is not working. So that is why I'm trying to build us on the concept. So we don't just go straight into scikit-learn and start saying model.fit, import scikit-learn, from scikit-learn import linear regression, this one, that one. But we are going to take our time to gain understanding before we move into that. So please try to understand all these that I'm currently explaining as much as you can. So next thing we're going to be looking about here is a regression line. A regression line. So this is another key concept in linear regression. So a regression line is basically a linear line showing the relationship between dependent and independent variables. So the regression line is always in the regression line in linear regression is always straight. So something you have to know, regression is a general term. So in regression, we can have different kinds of regression. So regression can map, what regression does that it maps relationship between two variables, two or more variables as we've seen in multiple independent variables. So, but some of these data or some of these variables, they are not all of them have a linear relationship. So in cases where they don't have a linear relationship, you can use other kinds of algorithms, right, to map them out. So it is still regression, but you would have to call it a different kind of regression. It's a different kind of regression. We have logistic regression, which I've talked about. So you would see when we look at it tomorrow, you see the line that is used to map the relationship. It's actually like an S shape. It's called sigmoid function, right? So I don't look at that tomorrow. But for linear regression, it is a straight line. The regression line is a straight line. We have polynomial regression, so which is used in mapping polynomials, lines that are not straight. Like so, those ones have a different regression line. The regression line is usually curved and it has a lot of shapes. But for linear regression, the regression line is always straight. That is what makes it linear, right? And a regression line can show two types of relationships. You can show a positive linear relationship, which I've talked about, and you can also show a negative linear relationship. So this should not be new to you, right? I've explained relationships using scatter plots, right? So if the dependent variable increases on the y-axis and the independent variable increases, so this is a positive linear relationship. I don't want to dwell much on that. I explained that already. So if you plot a scatter plot, now you will now understand how some of these visualization will land come in handy. Like a scatter plot now, you would use it very, very well in assessing the relationship between two variables. So if the two variables are, let's say, moving or scattered, like the one we saw the other time, your assignment, the variables, the points are just scattered everywhere, right? You would know that there is really no much relationship between these variables, right? But if it's actually tightly spaced and moving in the same direction, you know that these two variables, they have a positive linear relationship, which basically can be, as this one is increasing, this other one too is increasing. So that is a positive linear relationship. So for a negative linear relationship, is basically as this one is increasing, this one is decreasing. So in a scatter plot, you are going to see the direction. I think I would like to just demonstrate that. So I believe visual learning is very, very, very helpful and useful. Let's just try to create a fake data and we can use to demonstrate relationship. So you understand it very well. Right. I want to create let me create two. Well, so this is just to show you. Let me see. Um, okay. So let's just try to um okay. Um just follow me here. I'm just trying to make sure that demonstrate all these things. So now let me just zoom out. So these are two variables I just created now. We have x variable and we have y variable. So I want to assess the relationship between them. So I just created randomly two different variables, right? Having different data points, and I created a scatter plot to the scatter plot is very, very good to visualize and see how they are related. So we can see here that there is an increase, like there's this linear relationship. As this one is increasing, this one too is increasing, but it is not perfectly linear. We can still see some data points here. This one is here, why when it's supposed to be here. So this is not a perfect linear relationship, right? So I can just I want to modify this so you see how this is going to be when there is a strong positive linear relationship. Let me remove some of the high values here. Let me remove 54, 14, 34. put 9, remove 56, leave it as is, remove 45 here, and put 10. So let's try again. Okay, this one is higher. So as you can see now, there is no longer correlation. Like it is now scattered, right? So the relationship between these two variables is not linear again. So if you plot this thing and you want to maybe use a linear regression algorithm to predict or make predictions, this is not going to actually give you a good model because there's no linear relationship between these two variables, as you can see here. Like, do you understand? I'm actually taking time to demonstrate this thing so we understand it very well. So in this case now, the assumption of linearity between the two variables has not been met. So it would not be wise to use linear regression to map relationship between these two variables. So this is just a very, very it's not a perfect example, but I hope it conveys what I'm trying to explain or the idea I'm trying to explain here. So yeah, that's it for that. So the regression line just shows the relationship between two dependent and independent variables, right? So now in this case where we have a scatter plot, in this case where we can see the graph, which graph? I believe, it's my network is okay. Okay. Can everyone see the chart I just plotted? Hello? Have I been disconnected? All right. Okay. So a regression line in this case now would be a straight line that is going to find the perfect fit for these two variables. That's what linear regression does. But that's what regression does in general. But in linear regression, it's a straight line that tries to find the perfect fit for these two between these two variables. So if you create a linear regression model, you usually the model is usually a straight line here. Like it would be probably from here in the middle here, going up like this. I wish I can demonstrate that, but I don't know why I can't notate on live recording. So that's what a regression line is. So this is what it usually is. So you have a straight line like this, and once we go, then you see some other pictures or graph I have there. So that is what linear relationship is for positive and negative relationship. So for a negative relationship, you have the line coming up, then going down as moving from left to right, and then the positive relationship is going down up, moving from left to right. So that is it for a regression line. So now these are examples of regression lines. So this is basically a model. This thing you are seeing now, let me zoom in. So this is a model. As you can see the label here, this is income. Income is the predictor or the independent variable, and this one here is the y variable, that is the dependent variable. So these two variables were plotted using scatter plot, as you can see here. This is the output of a linear regression model. So this is a very strong linear relationship, right? Positive linear relationship. And this line you are seeing here that is passing in the middle is the linear regression model. So what this line is actually the predicted value. So this is the prediction, right? So we're going to go all over that so you understand. But this is basically what you should expect when doing a linear regression, or when you see a linear or when you think of a linear regression model. This is what you should visualize, right? So two variables. This for simple linear regression, which we're going to talk about. This for two variables, right? The dependent and the independent variable, and then they are plotted. You see that they have a strong relationship, and we now have the line. This line here is the regression line. This is the regression line that I was talking about that actually captures the relationship between the two variables. So we have another one here. So this one basically just explains to us. Let me see if I can. Okay, yeah. So this one here, as you can see, it gives us explanation. This is where the dependent variable is, and this is your independent variable. And then these are the data points that we have, the different data points, and this is the line of regression. So this is line of regression. So this line is your predicted value, and all these data points are your actual values. So you have labels when you bring your data to your model. Your data has labels, right? So this all these things you're seeing, they are actually the actual values based on your model. And what the computer or what the machine was able to learn is this line. So it's this line. So let's assume in this particular case, let me zoom in. In this particular case now, we have someone that earns okay, this income you can see here is multiplied by 10,000. So this place is 20,000. Someone that earns $20,000 would would not be so happy as someone that earns let's say $60,000. Right, so that is the interpretation of this particular graph now. So, but what this line means is that this two here, this $20,000 now, for the prediction, we're going to be having a value around here. So if you trace these two, if you trace a line up here to this line, then that is going to be the predicted value for people that have, or the predicted value of, or the happiness score for people that earn $20,000. So that is what the machine was able to predict, right? So if we come here, let's say we have in this place we have $30,000 or $30,000, we will trace it up to this line here. This is the predicted value. So if we trace it here and then we trace it to happiness score, we are going to get a value for happiness score that was predicted by the model. So anywhere in this line, any point in this line is a predicted value for the corresponding independent variable. So, but all these dots you are seeing here, they are the actual values that you have in your data set. So now, if you should look at it, there's an obvious error, right? The error here is that the predicted value now is not exactly the actual value. So in this case now, we have a data point here. Let me zoom in very well. We have this data point here, this one that I'm moving around now. This particular data point is pointing at what I think maybe 0 point something here. And if we trace it to this the dependent or the independent variable, it should be around 2 point something or 20 something $1,000. So that is the actual value. But what the computer predicted, if you come up here, trace it up to this particular place, for this same 20 something thousand, the computer predicted is a happiness score of 2, which is not accurate because the actual data, the happiness score for this particular income, 20 something thousand here, is around 0 point something. So that is actually something that you face a lot in machine learning. The predicted values are not always correct. They are not always correct. So if you compare them with the actual value, there's a gap, there's an error. And that is the aim of machine learning, to reduce that error as much as possible. I hope I'm able to capture all these things in class so you understand. We will just understand and get the idea of it. So let's just move on. As we're moving on, I believe it will be coming or be getting clearer. So we have types of regression. We have two types of regression. We have simple linear regression and we have multiple linear regression. So what I've been talking about since is a simple linear regression. Remember when we talked about the independent variable, if you have one independent variable, it's a simple linear regression. If you have several independent variables, then you'll be using multiple linear regression. So a simple linear regression is not always practical. It's not always practical. So what you'll be using almost all the time is a multiple linear regression. So a multiple linear regression is when you have multiple variables, right? That is the independent variables in this case that is being used to predict the dependent variable. So this is just the idea of the whole thing. So as you can see here, in a simple linear regression, there is one independent variable and one dependent variable. So the model estimates the slope and intercept. So although this one is just for your own sake or for extra knowledge, this slope and intercept now, they're actually what determines how this line will be shaped. This particular place is the intercept, right? If you remember your straight line graph, let me go to the other one. So this particular line, yeah, this line vertical is your intercept. So wherever this straight line meets this vertical line is your intercept, right? And the slope is the how exactly will I capture this now? Is how straight the line is, or the rate of change. I don't use that because some of us might not understand. Is how the line is aligned exactly. Thank you very much. That word was eluding me. The steepness of the line. Thank you. So the slope in this case is the steepness of this line. So these are the two things that the linear regression model is trying to learn: the intercept and the slope. So if we come here now, for this particular model, if we draw this line to complete or to touch this place, you see that the intercept is around 0.1 point something. And the slope, if you calculate it, the slope might be low because the curve or the line is not so steep. So if we change any of those parameters, you see that this line will change. This line will change. If we change the slope now, if we change the intercept to 2, this line will come up here and start from here and go like this, with the slope remaining the same. If we change this, if we leave the intercept static and we change the slope, the line will come up a little bit. I wish I can visualize this, although there's something I will show us at the end of the class, which will help. So the slope and the intercept now are the two things that the linear regression model is trying to learn. So remember I showed us this formula, right? I told us about this beta 0 and beta 1, right? This beta 0 is the intercept and this beta 2 is the slope. So these are the two things, the parameters. They are called parameters in machine learning. So they are the things or the values that the machine learning algorithm is trying to learn. So there's an infinite combination of slope and intercept value that we can have for this particular data or this particular relationship. But the one that best minimizes the error is the one that the model will use to model the relationship. I don't know if we are following. So that is basically it. So I need you to understand that about slope and intercept. So the model estimates the slope and intercept of the line of best fit, right? So the line of best fit is the line, as I've said already, that minimizes the error between the actual value, which are these dots that we are seeing here, and the predicted value, which is this line. This line are the predicted values of our of the model, right? So if we take if we subtract or we kind of get the error for the entire data set, we're going to get a particular error for this particular model, right? If we change the slope a little bit and change the intercept a little bit, it's going to give us a different line. And if we now calculate the error for that new line or that new model, it's going to give us a different error. So the model go through several iterations of lines that has the lowest and picks the one that has the lowest possible error, and gives it and uses it as for prediction. So that's basically linear regression, and that is basically the idea behind machine learning. It's basically trying to minimize the error between the predicted value and the actual value. So for supervised machine learning that has an actual value, that is the label. This is how we get our error, and this is how we make our machine learning to be very, very effective. So moving on, we have multiple linear regression, right? We have multiple linear regression. So in multiple linear regression, it's used to model relationships between a single dependent variable and multiple independent variables. As I've said before, I keep repeating myself, is used to model a relationship between a single dependent variable and multiple independent variables. So visualizing a simple linear regression is very straightforward, as we've done here when we visualize different variables in the y and the x axis. It's very straightforward. But visualizing relationship between multiple variables is very difficult. So we are actually limited visualizing just three-dimensional relationship. We can't go beyond. This world is we interact in a three-dimensional world, so we can understand what a four-dimensional world is. Why I'm bringing dimension here. So when we come to in this case now, in this case, we have x and y. Let me use the other one. In this particular model now, we have two variables, the income and the happiness. So this is two-dimensional data sets or two-dimensional data, right? We have just one, the happiness here and the income here. So when we are looking at multiple linear regression, we're looking at multiple variables, how they relate together. So we have plenty additional variable added to this particular. And if we have two-dimensional, if we have three-dimensional, if we have four variables, it's four-dimensional. If we have five variables, it's five-dimensional. So we can have like 10 variables in a data that is used to predict a particular variable. That is the dependent variable. So that is a 10-dimensional data or data set. So it's impossible to visualize it. So we are only limited to just visualizing three-dimensional variables. So we cannot visualize four dimensions. So I just wanted to point that out. So that is just to show you how linear regression is a little bit more difficult to understand, right? In terms of showing it on a graph. So you just have to use numbers to get an idea of the relationship between the variables. So now there's a different formula for multiple linear regression. Remember, for simple linear regression, it was to intercept, that is the beta 0, and the slope with multiplied by the data. That is your variable, right? That you're trying to predict, using to predict the dependent variable. So you remember we have just one variable here, so we have just one x here. But for multiple linear regression, depending on the number of variables we have, we're going to have additional slopes, right? So we have different slopes for different variable. So in this case, we have just one intercept because to start from just one point, right? So it now for the first variable. So in this case, we have depending on the number of variables we have, we'll have the first variable with its slope, the second variable, that is x2 with its own slope, the third variable, and so on and so on and so on until we've exhausted all the variables we have in that data set. So that is what that is the formula for a multiple linear regression. But you are not going to be you don't have to worry so much about it. It's just for you to understand it. You won't do any calculation, trust me, unless you want to go into research in machine learning. But for the sake of implementation, all the tools have been created for us to just implement these things that we are talking about. All these formulas that we're talking about, we don't even need to use them, like basically to use them. So we can just call in a function that will do all these things for us. So but you need to understand this so you'll be able to know which function to use and how to use them effectively. So we've talked about the types of linear regression, right? Simple linear regression and multiple linear regression. So I would also go over what we call evaluation metrics. If you remember in the last class, before I go on, let me know if we are still following, and let me know if you're understanding what I've been explaining so far in the live class. I'm waiting for your feedbacks. or is it getting very technical? Okay, I'm waiting for us to give our feedbacks. All right, someone saying it's technical. Oh, but very technical. Yeah, the pressure is getting worse. Yeah, you don't expect to still be on the same level, right? So you have to adjust yourself. That's how you grow. You meet new challenges and you overcome. So the same way the you didn't understand all these things that we did in Python and the rest when we started, it's the same way you didn't understand this one too as we are start. Exactly. It's just like when you were introduced to Python. So you get to understand it, like definitely. So just be just pay attention and get the most you can from this particular class, right? So it will definitely be easy for you. It's just like when I was also learning to like it was a lot. Like I was like, how do I relate all this? How do I understand all this? But now I'm here. It's just easy. So just consistency and just try as much as you can to to just pay attention to the class and also learn on your own to and practice as well. So all those stuff. So now we're going to look at the evaluation metrics used in linear regression. So I remember when I was talking about the different phases of the data science life cycle. We talked about the model, the part where you clean your data, the parts where you do all this processing. I also talked about the part where you do model evaluation. After you've created your model, you now evaluate your model. So model evaluation is very, very important in machine learning because that is when you know if your model is very good or not. So by next week, by God's grace, when we start the practical aspect of it, you would see all these things in action. So we're just talking theoretical. It's looking abstract, right? But once we start, you're going to understand how they work. So now we're going to talk about some evaluation metrics used in linear regression. So for each algorithm, each algorithm, we have different ways we evaluate it. So you also have to learn how we evaluate each algorithm or each model. Yeah, basically each algorithm. So when you create a model using an algorithm, you need to evaluate that model to be sure that that model is performing well. So for a linear regression model, we have we have what we call cost function. Cost function. So these are new terminologies, right? So we also have what we call loss function. So the cost function is actually what we use to assess the performance of our model. If our cost function is the value for our cost function is very high, that means there's a lot of error in our model. We have to make it better. We have to like improve on it, right? So the cost function is basically the error of our entire model. Remember when I was talking about the differences between the predicted and the actual value. So the cost function is when we compute each of the difference, each of them. Can we hear me? All right, let me reshare my screen. My network went off for a minute there. Okay, so now when we have each of the data points, right? All these dots here represent each data point. So to compute the cost function or the error of this model, we actually are going to have to get the difference between this actual value and the corresponding predicted value. So the predicted value is the values on this line. So this line itself, they point to a value. If you draw the if you draw a straight line to this particular axis, y-axis, you get a value, right? That is a value for that particular line. So you will do that, subtract each of them, and then you now just subtract them, sum them up, and you get a value. So that is the value of the cost function. So the cost function is what we almost always try to reduce during our linear evaluation, linear regression evaluation. So, or yeah, basically during training. So during evaluation, we get the value and we see if the value is good or not. So we have several ways to compute our cost functions, right? So we have what we call mean square error. So all these things are just formulas. All these things are just formulas. Mean squared error, root mean squared error, mean absolute error, R squared, adjusted R squared. So all these things are just formula. Like it is not anything big, right? It's just different ways to compute the error of our model. So the error of our model is also called a residual, something that you should also know. So whenever we talk about residual, we are talking about the error, right? So you just keep that at the back of your mind or know that. So let's just go through each of them. So for mean squared error is basically a metric tool that measures the model error, the model performance. So these are different approaches. In this case, we actually square all the errors. We subtract the errors, right? And we square everything and then get the average. That is what mean squared error is, right? So that is basically what we do there. There's a formula for that. I didn't want to bring in that formula so it will not make it so intimidating, because you mostly not need that, especially unless you want to take exams or you want to go deeper into it, then you can always go and research that. But for the sake of this class, I'm just going to build our intuition on all these things. So we also have root mean squared error. So root mean squared error, right? We are now introducing a square root to the error that we've already squared and divided by the average. So these are just mathematical terms, like those formulas, right? So you just need to understand what these things are doing. So we have mean absolute error. So the reason why we have several errors here and we don't have one error for this case is because some of these errors, they have disadvantages. There are some cases where it's not good to use this particular metric, right? So I'm going to let me just go over that. So for root mean square error, is actually used when okay, we'll talk about that one when we are done with that. So we have mean absolute error, right? So mean absolute error is still the same thing, right? But what we are trying to do, we are just trying to get the absolute difference, right? So absolute difference is removing the negative sign, getting the difference and removing the negative sign, and getting the average. So I don't want to go deep into that, but basically these are what these metrics do. They compute the error of the model, right, of that particular model, and shows us and gives us a value. That value is what we're now going to use to judge if our model is performing well or not, right? So you can see here that mean absolute error is less sensitive to outliers. So if you come here now, this root mean square, this mean square error is actually can actually give you a false value or a false sense of how your model is performing, because there sometimes you might have outliers in your data. So if it squares that outlier, the square of that outlier, which is a very big number, will affect the general value, which is going to make it like bigger than it's supposed to be. So there are some cases where we don't use mean square error because of this particular problem. So we just use mean absolute error, right? So, but it doesn't mean square error is not a good metric. In the cases where you use it, when you know you don't have outliers, then it's fine, right? So, then we have R squared. Now, this R squared is what I want you to understand very well.
So R squared is a metric that shows you how well your independent variable is predicting the dependent variable. Remember I told us about correlation. Correlation has a value between 0 and 1, right? The sign or the value for correlation is R, a small letter R. While for regression is R squared. So R squared. So the R squared here is trying to tell us how much the independent variable is predicting the dependent variable. So it's a very, very good metric. It's a very good value to use to understand your model performance. So you can see here, this metric represents the proportion of variance. These are all jargons. All these things are just jargons. But basically what I've said is what it means. So it represents the proportion of variance in the dependent variable that is explained by the independent variable or variables in your model. So the value ranges from 0 to 1. All these ones I've talked about here, mean absolute error, root mean squared error, and mean squared error, they don't really have a range, right? So, but this R squared has a range. So it ranges from 0 to 1. So if the R squared of your model is very high, it's almost impossible to get 1. But if it is very, very high, right, then that means your independent variable is strongly predicting the or has a very strong influence on the dependent variable, right? So that is what R squared is, a very important metric to know. All these ones I just go and went over. You need to know them, right? You definitely use them while creating or building your model. But this R squared is something that you might even see outside of these things. It's something that is very common in statistics. So in the case of linear regression, I told you we have independent variable and dependent variable. So when you create a model, right, you get several values. So you get a value, particular value that is R squared. So the R squared now, the value is between 0 and 1, right? So if it is close to 0, that means the independent variables, right, they're actually not a strong predictor for the dependent variable. So you now start to reconsider whether you remove it or you would introduce more variables that are strong predictors, right? So it's just like saying you want to use your height. You want to use height to predict exam score. So if you create this model and you get if you use linear regression on these two variables, you get the R squared that is very low. Why? Because height is not a strong predictor. We all know that height, I don't know if there's any connection between height and exam score, right? But we all know that there's no connection. So the R square will be very low. That's basically what R square is. But in the case where we have study hour, and exam score, the R square will be high because time that you put into studying would actually affect what you get in your exam in a way. So the R square will be high. So that is what R square is. It just gives you an idea of how your independent variable is explaining or predicting the influence it has on your dependent variable. This is different from correlation. Correlation just shows you the relationship between two variables moving in the same direction or not. For this R squared, R squared value, which is also called regression value, is giving you an insight into how these two variables or one variable influences another variable. That is basically the core idea in linear regression. So we also have adjusted R square. So this is just basically a modification of R square. So so what we have here is that when you add more variable to what you already have, let's say you created a model with just one variable, right? You ran that model, you got your R squared. You saw that R squared is, let's say, 0.567 or 0.57, right? So you were like, this is a good one, but you need a higher value. So you now add another variable, right, to the other variable, right, and you now created another model. And then in you're going to get in the new model you get an adjusted R square. So the adjusted R square tells you if the new variable you added is actually adding or helping you better predict your outcome or the dependent data or the dependent variable. So these are just different things that you use to understand how your model is performing. So you might not really understand it now, but as you're going on, as you're moving, you'll be getting insight and intuition on how these things work and when and how to pay attention to any of them, right? So you definitely gain mastery over all these things. You just need time. Just need time and your dedication, effort. Even outside of these classes and these lectures and assignments, you just on your own you can read more. The textbook is there too. You can. There's another textbook that I sent to the group. Um, Thanks to the assistant class rep, he actually sent it to me, which I found very useful. But there's something I found useful personally before, and I sent it to the group that I hope everyone has seen that. So it's actually a book dedicated to machine learning. This one is not just data science. This one is for machine learning itself. So it's going to give you more details on all these things, right? Explaining them in depth. Videos are there on YouTube that you can watch. You can watch single video on linear regression. The visuals is there. So there are people that are very good at creating visuals on YouTube. So they will help you understand all this and it will give you a better and holistic understanding of what we have been saying. So our own is just try as much as possible to give you foundations and try to help you understand it. But you can go at the extra mile to help yourself too, right? So for some of us that might not really be getting it at this point, so this is just what you should do. Just stay consistent with learning and you definitely get it. I started somewhere too, like everybody that you know that is good at machine learning, data science, what have you, they started somewhere. So the only thing that differentiates them from you is just time and dedication, right? So that's just it. That's if you really want this. So I've gone over some of these things, right? I've gone over a lot of things in this class. So I'm going to try as I can to complete what we have for today and then do a little demonstration. So this is just telling us how to choose the right metric, right? So choosing the right metric. So we would have to choose a particular metric. We don't use everything, although you can check each of them and just use it to understand, but you need to choose a particular one you use to evaluate your model. So you can choose them based on different criteria, right? In the error magnitude. So if you are concerned about that, you can use the root mean square error, right? So it actually reduces the value of your error. So it doesn't give you a very large value, unlike mean squared error. It gives you a very large value of error. But root mean square is you take the square root of the mean squared error. So it will reduce the value of the error for you. So we also have outliers. If your data have a lot of outliers, it's best to use mean absolute error. So mean absolute error is robust to outliers. So it gives you a better error value compared to root mean squared error and mean squared error in cases where you have outliers. So a more realistic one as well. So we also have model complexity. So you see here, you can use adjusted R square to compare models with different numbers of independent variables, as you can see, exactly what I explained. So if you have different models with different numbers of independent variables, it's best to use your adjusted R square to see how each of them is performing with the added variable. So you know if you remove that variable or you add it. If the R squared is increased, right, you know that, oh, this new variable I added actually helped in this particular model. So leave it. But if it doesn't change, you can just remove it. So that these are the things to about when building a model using linear regression. I'll quickly go over the assumptions of linear regression. So I remember saying that there are things to take note of before using linear regression. I've mentioned some of them, right? The first one here is linear relationship. So your model has to have a linear relationship. Like there is no other way around that. it has to have a linear relationship between the independent variable or variables and the dependent variable. So you always have only one dependent variable. You can't have two dependent variables. It's not possible to predict two things at the same time. So you have just one dependent variable and either several independent variables or one. But to use linear regression, there must be a linear relationship between these variables, right? So, but sometimes it's usually hard to model the relationship linearly of multiple variables. But just as we go on, we'll talk about that too. So we have, as you can see here, we are illustrating the different kind of relationship we have. So we have the first one. This is a linear relationship, a positive linear relationship. We have the second one, which is still a linear relationship, but it's a negative linear relationship. Then we have this third one. This is exactly what I was talking about. This is a non-linear relationship. It is not straight. It is curved, right? So it has to be straight. The relationship has to be straight for you to use linear regression. So this is the first assumption and a very, very important core assumption in using linear regression. So we also have independence of errors. So as I said before, the errors is the difference between the predicted value and the actual value. That is the error. So we get the difference for each of the data points and we sum everything up and get the average. So we'll get the average error of our model, right? So independence of errors. So in this case, we just ensure that the errors are independent of each other. So we use visuals to get or to see that our data is meeting all these assumptions. So we'll plot the errors now. When we get the errors, we can actually get them as values, right, in a NumPy array, and we can plot them, right? So if we see something like this, then there's no independence. It's a random. But if we see something like this, that means there is a relationship between the errors. So this is deviating from the assumption of linear regression. So this is another assumption, right? And we also have another one called homoskedasticity. Homoskedasticity. That is actually a mouthful. Sometimes I don't even get it wrong, right? But what I usually call it is constant variance, right? Or equality of variance. So I love how we have visuals here to help you understand it. So this is what homoskedasticity means. Like if you plot your residuals, which is your error, on the scatter plot and you draw a line, they should be like equally at equal distance along the regression line. That is what equality of variance is in this case. So if we have something like this that is deviating, like the variance here is not the same as the variance here, that is deviating from this particular assumption. So it's not be really wise or advised to use linear regression. So we also have another assumption, normality of error, right? Normality of error. So I remember we talked about normal distribution in the last class while talking about histogram. So you can, all these things is just on the errors itself, right? So you have to have trained your model and you get the error and then use that error to check if the assumptions are met. So you can plot your error and check if it is normally distributed. So in this case, the errors are actually normally distributed. So you can actually use the linear regression to confidently run your prediction or do what it is that you want to do. So in this case, it's not normally distributed, right? I don't even understand the distribution here. So just quickly going over it. We also have no multicollinearity. I'm just trying to imagine how some of us will be looking at the screen right now. Like, what are all these names? Like, how am I going to just know all these things? So these are actually new terms. Actually, they are new terms. So, but you get used to it. I will keep saying that. So no multicollinearity. So multicollinearity is actually when the independent variables are correlated with themselves. Right. So if you check the correlation of between the different independent variables, you see that they are highly correlated. Then you either need to remove some of the variables because they are redundant, right? Because it actually you can't actually tell which of them is affecting or influencing the dependent variable. So the truth is that you don't need to go through each of these assumptions before you use linear regression. Most of the time, most people don't even go through these assumptions, right? Sometimes myself, I don't really go through all these assumptions. You just assume that your data meets all these assumptions. Like just assume. And most of the time your data meets this assumption. So don't get don't get overwhelmed by all these things we are saying. So these are just things that you just have to know. But when it comes to the practical aspect of it, it is quite different, right? So it's not like you start going through all these things one by one to be sure. Oh, let me check if the variables are equal. Let me check this. No, 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 no. Right. Most of the time, you just build your model and assume that it meets all these assumptions. So it is when you are now getting an error that is so big that you now have to start checking the assumptions to ensure that these assumptions are actually there, right? So that is just it. And the last one, no autocorrelation. So basically, it's about the errors not correlating with themselves. Okay. It's just the same thing as this one we said the other time, right? Okay, so that's actually it for linear regression. At least we've tried to capture the basic concepts in linear regression. So it's important to, there's something I want to note. It's important to remember that these assumptions and real world data may not perfectly adhere to them. However, checking for this assumption and regression evaluation can help improve the reliability and interpretability of your linear regression model. So, yeah, this is just telling you that the data that you see out there, they are not perfect, right? So most of them are not perfectly, they're not perfectly following the assumptions. Well, they're just sometimes you just have to do some transformations to ensure that it is meeting at least this linear relationship assumption is very important to that it is met. Like this one is very, very important. That's why I said data science is a creative stuff, right? You need to know a lot of things and then use what you know to do what you want to do. So there's no defined path for everything, every approach. You try, you test and try until you've gotten the perfect thing or the perfect result or outcome that you want. So that is basically it for linear regression. Like that is basically it. Although it's not the entire thing, but it's good to keep you get you started with what we are going to be doing. So today we've tried to cover the concept, the theoretical part. Next week Saturday we're going to now start the coding part. Okay, how do we implement linear regression? Actually, that is when I'm going to introduce us to scikit-learn and how to pre-process data, split our data into train and test, validation, and a whole lot of other things. So if you are already complaining now, I wonder what you'll be doing next week Saturday. So buckle up. We're just starting. And that is not to scare you anyways, it's just to help you get ready and prepare. So that is it for linear regression. Just go ahead and read more on this. Yeah, please read more on this. Try to understand those things, concepts you don't understand. You can look them up, watch YouTube videos on the math assignment you go do like this. Calm down. So yeah. So there's a particular website that I will drop the link on the Google Classroom after this class. So the it kind of visualizes a linear regression. So I hope you can see my screen. So now this is these are plotted data points. All these blue things you are seeing, they are data points of two variables, right? So in this particular case, some of them are negative values. That's why we have them crossing this particular axis here, but don't bother about that. All right, let me randomize this data to see if it will change. Okay, so this is just change data. All right. So now you see several things here. First of all, you're seeing the blue dots, right? These are the data points. you are seeing the red line. This is the um, regression line. This is the model, right? So you see that there's a line being drawn from each of the data points to the red line. Now, this line is the difference between the actual value and the predicted value by the model, right? So this is the error. This is error for one particular data point. This is error for another data point. This is error for another. So to get the total error, you will add all the errors for each of the data points, and then using either mean squared error, you can square each of them and add them and then divide them by the and get the average, right? For mean squared error. For root mean squared error, when you've got a mean squared error, you now use square root to get the root mean squared error. So this should just give you an intuition of what is happening here in linear regression. So we can actually change the slope and intercept. Okay, we can actually change the slope and intercept, right? If I come here and raise this thing up, I'm actually changing the slope. So I'm changing the slope. I'm changing the slope, as you can see. So you will realize that now, as I'm changing this slope, the error will be reducing. Why? Because the distance between this actual value and the newly predicted value here will be lower than when it was here, right? So linear regression tries to get the best line that will give you the lowest error. So the best line should be around here. So if I come here, I can change the intercept. I can come here and change the intercept too, right? As you can see. So these are the two, as I said before, these are the two things that the model tried to learn: the value for the slope and the value for the intercept. So it would tweak them to a point where the errors are minimized. So if I show the regression line here, this is the best fit. This blue line that you are seeing now is the best line for this particular data points that we have. So this is basically what linear regression is. This is just it. If you understand this, you understand everything about linear regression. So I dropped the link. I'll drop the link on the Google Classroom so you can just play with it. So if I randomize this data, you see for different data points, we have different regression lines and the different slope and intercept, right? So this is basically how what linear regression is. So yeah, that's just it. That's just it. You can play with it yourself. This particular website is very good for visualizing a lot of things, right? So you see the instruction here, right? When you try to fit the data best with the red line, the sum of squared error, as you can see, for your line appear right next to the target sum of squared. So it's just basically what we've talked about. So this website is very, very good, right? You can there are a lot of things that you can do, but this particular class we had today, you can actually go here and try to just play around with it to understand it better. So that's going to be it for this class. Time for questions, please. If you have any question, let me know. Let me know. So yeah, we've come to the end of the class, so you can now ask your questions. Everybody was talking about how technical it is. So if you have any question, please ask a question. No question. Is that we understand it perfectly that we don't have any question or what? Or we don't even understand it enough to ask question? I don't understand. Like, what's the problem? Okay, so I'll just wait for like a minute and then we're going to end the class. So you can ask on the group chat as well, or if you can't speak, you can just type. You can actually ask a question in the group chat. Just type out your question, and if I see it, I'm going to answer them. So that is the essence of the live class too.
So Omolade, if I'm to ask question, we'll ask you to take everything. So you just go out and rewatch it. Yeah, it's better you rewatch it. So um, think that one is not a question. That is just trying to understand the whole thing. So I'm waiting for us. Once it's 1 minute, I'm going to end this class. I'm going to end this class. So for the assignment, we're not really going to have any technical assignment for the week. It's just going to be a conceptual assignment. So yeah, we're not going to be doing any coding or a lot of maths, but yeah, you see it when it's ready. So what is actually the difference between machine learning and deep learning and deep machine learning? So okay, yeah, if you remember in the last class, I showed us a particular chart that has AI, right, as the outermost field. AI now has machine learning in it, and then machine learning now has deep learning. So machine learning is like the broader aspect of it, and deep learning is a subset of machine learning. So deep learning is basically called deep because of what the kind of algorithm it uses. It uses what we call artificial neural networks. So this are actually all different thing. So this artificial neural network have what we call hidden layers. So these hidden layers is what maps out relationship between an input and an output. And we can have a lot of hidden layers. And in those hidden layers, they can become so deep that we don't even understand what is happening in it. So that's how we come about the word deep learning. So it's more advanced form of machine learning that we use nowadays. So all the things you are saying in AI, they actually use deep learning, right? So if you want to go into that one, then that's fine. That's fine. So I believe that has answered the question. So okay, no wonder. No wonder NIT used 2 months to teach us statistics. Actually, the time frame is not actually sufficient, to be honest, to do everything that you we need to do in data science because data science is a combination of several fields like statistics, math, and if we want an elaborate course on or yeah on data science, you'd have to take linear algebra, you have to take calculus, you have to take statistics, you have to take a lot of other things, right? So to get a holistic, a very deep understanding of data science. But most of the time you don't use all this knowledge. So the practical aspect of it will require you to just understand some of these fundamentals that I'm teaching you now. So the other ones are like extra knowledge, which is very, very good. So yeah, that is just it. And I'll be ending the class now. And so please, if you still have any question, you can as well still drop it on the group chat, and I will do well to answer them once I see it. So please, yeah, enjoy the rest of your day. See you tomorrow by 5 p.m.